Hello everyone, this is Kai Mandrasina and Sam Zimba doing our MBSE presentation on learning MBSE and unlearning improv. Today we'll be talking about Volvo and the MBT70 project, how they relate to MBSE, PLM, and what we have learned throughout this class. Volvo is a large automotive manufacturer whose products range from trucks, buses, construction equipment, and industrial engines. They employ almost 100,000 people and receive over 200,000 orders per year. Recently, they made a digital transformation, implementing several new technologies to accommodate for their massive enterprise and growing technologies. As they were making this change, their main concern was to maintain a high quality. As with everything changing to a new platform, many important production aspects may have been lost. This is where model-based system engineering comes in. Several different diagrams can be made to ensure that this process goes smoothly. For example, a requirements diagram was likely made to ensure that each aspect of all their products were accounted for. Also, questions like what they want to get out of their models and what service the new platform provides may be answered and documented.
The MBT70 project began in the 1960s, yet attempted to implement cutting-edge technologies and processes ahead of its time. The project was a collaboration between the US Army and the German Bundeswehr, with an interest in standardization of parts and new weapon systems. The different armies each had their own engineering teams and contracts, but featured a multinational joint design team to set requirements and regulations for the project. Unfortunately, this joint team was unable to prevent issues in design duplicity, communication of changes in requirements, and hierarchies of authority.
Approaching this digital transformation, Volvo took a bottom-up approach where the concerns of the frontline workers were at the highest priority. This was one of the many strategies that we learned about in implementing a PLM software within a company. With Volvo using Creo as a CAD software, they naturally implemented several other PTC softwares. They used the PLM software Windchill, which allowed for the full product lifecycle to be tracked in real time along with all the product data that comes with it. Several other capabilities became available to Volvo through this, including workflows, the digital thread, and the digital twin. Volvo used the digital twin to implement augmented reality to improve engine quality control by allowing operators to recall a 3D model to inspect the part. Volvo also implemented an industrial Internet of Things platform called ThingWorks. This allowed for a single source of truth throughout all their models. As seen in the diagram, ThingWorks allows for all of the product data to be recorded in one place where it can be analyzed and used to improve the product. Throughout this process, Volvo saw improved efficiency, lower cost, reduced training time, reduced time to market for new products, and the capability to develop new uses for this cutting-edge technology.
The MBT70 project ultimately failed and was cancelled in the 1970s. They took a bottom-up approach in development, which we learned could cause issues with complex designs, as a system designed around many existing and separate components is less efficient than components designed for a system. Without PLM, this old approach led immediately to duplicate designs, and in a few short years, American and German models had little resemblance. As we learned, processes like configuration management, something the joint development team did not have at the time, can be used to track changes in requirements and manage the large volume of standards such a project contains.
As time goes on, technology will become more advanced, and the amount of product data that comes with it will increase just as fast. With that said, the need for a digital transformation is booming and is becoming a new standard for any large enterprise to succeed. The combination of PLM softwares, the digital thread, the digital twin, and a single source of truth leads companies to several benefits. They enable superior communication throughout the company using workflows, allow for data from multiple sources to be visualized in a single place via the digital thread, and provide a very efficient way to access large amounts of product data. These components are keys to success within an enterprise, providing crucial benefits, saving companies time and money.
Engineers at the time simply did not have the tools necessary to complete a visionary project like the MBT-70. This provides us a rare glimpse of how MBSE has changed the engineering process. We learned that modern-day configuration and change management can track and manage changes to designs and their requirements, preventing loss of control of the models. Additionally, a digital transformation would have allowed the design teams to use digital twins bound by digital threads, leading to a single model, aka a single source of truth, instead of multiple prototypes. Modern PLM could have enabled such a massive collaboration of international engineering. Volvo's PLM implementation and the MBT-70 project provide us with a unique view of the benefits of model-based systems engineering, and how PLM has shaped not only engineering, but how we think about engineering.